So first of all, thank you for joining, and many thanks to the organizers for making this platform available to speak. I'm first time speaking over here, and what I'm going to talk about is a little bit about how Synapse Serverless is going to play a role in building data mesh architecture. So yeah, like data mesh is quite a new word around the town, and what I want to bring over here is an engineer's point of view that how we can utilize Synapse Serverless to build candidates of data products. So going next. So who am I? I work as a data engineer at Element 61. This is my LinkedIn contact to get in touch. And the presentation I am doing today does not necessarily express my employer's view, the disclaimer as it goes. The things which I'll be covering today is starting with why I want to talk about this part, how data mesh evolution has happened, and then looking into the data mesh principles, what are the 4 principles, and what are the experience planes over here, and what are domains and data products, and then relating it with Synapse Serverless, that how we can build source-aligned data products using Synapse Serverless. I'll go through where does it fit in the data mesh plane, and then also what are the basic principles of Synapse we can use to build a framework which can help us out building data products. So the first one goes data mesh evolution. Why I want to talk about it is it goes with all the age-old questions which we have been trying to answer about in the analytics world, that what is the time to market a product, and we have got a lot of data, it is creating data swamps. But the most important one, which I feel is close to my heart, is whenever I go to a customer, the question comes that, okay, I'm given a business use case to solve, and that belongs to a business process. I start with building reports, feels like I have a bullseye to score. But while I'm in between the implementation, it also does, the attention shifts to a major question, more like looking at bird's eye view of it, that what else can you bring from this data? So that feels like, okay, we do have a very tight coupling right now, which needs to be generalized more, that we can bring as many data products as possible as early phases and then find the insights from it. So that's the reason I feel that data mesh does play a role over there, that you can build your data products, let people decide on the consumer side that which one do they want to use, get something new which needs to be built on the data based on the needs of consumers. But all this being done very dynamically is what we are trying to achieve through data mesh. So early on, these questions had been answered, like we had the data warehouse system to build analytical reports, and then came like, okay, dealing with the big data, unstructured data, and also the data lake came into picture. But as the solutions came, so does the new problems also existed, that how are we dealing with structured data? So there was data warehouse, but then how are we dealing with big data? So the data lake came. But the question which still remains is, if there is data quality issues, who is going to handle that? Who do we go to? Is it the technical team, or is it technical team throws the ball in others' court that, okay, it is the source team whom we need to contact? So these are the questions which are very prominent one, and all these questions are being answered through the principles of data mesh. So this is what the future looks like, that the data sets driven as a product, not as the process, as the byproduct of the processes, and more like going through a life cycle of data, that you create, you discover the data, you use it, if you don't find it as the right candidate, you discard it. More like data speaking to each other. That's how the future looks like. So yeah. So the challenge is over here, what we see that, okay, we have had that we were using data as an artifact that was more like a byproduct, what data mesh principle suggests that we should be using data as a product rather using as a byproduct. And like I was saying, that it is we have been doing is that trying to answer a single business process. So building a report very much tightly coupled with the business process. So we should be trying to decentralize that a single data product can be used across multiple domains and all. And I think we are already way ahead in using Agile CI/CD DevOps concepts while building our products. But then, yeah, this is right now we are more process centric than being data centric. So these are some of the challenges which data mesh principles tries to address. Another one being that what are the multiple interfaces you can share the data with. For example, somebody can ask the data to be used as only as API endpoints. So though it has got SQL interfaces, you want to use API endpoints. So building a common platform which provides the data through API endpoints is also something, a framework to be built in data mesh. So, and another one that's more like a social approach, I would say, that who takes the ownership of data. These things, that's more like in the governance part coming in. So this is like more of shift from data being treated as a monolithic service to a decentralized service. Going next, looking into a zoomed in view of what the data mesh principles are. So these are the data mesh four principles of data mesh. One says that domain ownership, more like trying to address that if something goes wrong, who do we go to? So that's a faster approachability, I would say. And when we talk about domain ownership, there are multiple domains which are defined there, that whether it is a source aligned domain data or a consumer aligned domain data, or in between the aggregates being built to serve these. So different domains. And then next one being data as a product. So again, like data not being treated as a byproduct of a system, but in itself being built as a product, which goes through the life cycle of creating the data product or deploying it, setting the privacy regulations, etc. And then having a self-serving data infrastructure, so which means that one can go and subscribe, discover the data they want to use, and then use it. So that's more like about self-serving data infrastructure. And then federated computational governance. So since we are talking about multiple nodes present on a mesh, they must have some of the rules which are governed on the whole, but they also will have a domain specific rules as well. So that's where the federated computational governance comes in picture. How these principles can be achieved in data mesh is as outlined from the architecture is through multiple planes. One being a mesh supervision plane, which has the capabilities of managing various nodes of data products, the securities of data products, and making it discoverable and explored on high level, making it available to everyone. And then there comes data infrastructure plane, which is more, I would say, the DevOps approach of it, that making the code in a way that can be reusable across different domains. It looks into the security principles, access control, the orchestration of data, and the CI/CD pipeline. And the one which I would say from a data engineer's point of view is most important, or where we want to know that how we do it or what we are going to do, is the data product developer experience plane, which talks all about creating a data product, managing the life cycle of data product. So that being said, it's more about the life cycle of a data product, where we see that how to create a data product, how to set the privacy policies, and how to deploy it and build and orchestrate it. So all about the data product is something data product developer experience plane handles and makes available to. This is something we are going to look later in detail about how Synapse Serverless can be a good fit to be put in data product developer experience plane. So these are the principles of data mesh and how this can be delivered through the various planes. Here goes the data product on the data product developer experience plane, and then self-serving through the data infrastructure plane, and the federated computational governance managed through all these planes. So the next one is, like we were talking about, the domain ownership. So, and I was saying that there are multiple different types of domains the data can be categorized into. One being source-aligned domain data. When we say source-aligned domain data, that's more like the data coming from the operational system, which are fit for consumer purposes, and from which you can derive the aggregates, build the transformations. It does the data coming in does change often, but it's kind of the use on top of it is kind of keeping it immutable. So that is where I see that Synapse Serverless makes a good fit over here, because the kind of use cases which Synapse Serverless supports is doing data exploration, building logical data warehouses, and building some data transformation. So that's my view is that we can use Synapse Serverless at its full capacity while building a source-aligned domain data. A few other domains are the aggregated domain data, which builds again building the transformation on top of source-aligned domain data, and then the last one, consumer-aligned. So mostly, I would say the reports, etc., which are ready to use. So those comes in the consumer-aligned domain data. Now, that's on the whole is what the domain looks like, but every domain can have multiple data products, and what a data product is basically the smallest unit which is present on in the data mesh nodes, and how a data product should look like, that it should have input port capabilities, that it can connect to the other data products, fetch the data, and then should have its own transformation logic, which should be more like reusable and automatically deployable, and then should have multiple output ports, as in said polyglot output port to support various uses. So that's what the data product is. And then I'm going to take you through that why I think that Synapse Serverless would be a good fit over here. First, being that what Synapse Serverless in general does is that, yes, you have data present on storage layer, and you show it in a relational format, and you serve the reporting layer. That's how, in general, a Synapse Serverless tool is used. The three different use cases it can support is that for data exploration, for logical data warehousing, or for building data transformations. So, where does it fit in a data experience plane? Like I was saying, that for in data engineers, it is the most important one is going to be data product developer experience plane. And the data developer experience plane, what it does is it supports the capabilities to build the life cycle of a data product. First one being creating a data product, where I say that using Synapse Serverless, Azure Functions, and web app, we can build a data product which would serve a source-aligned domain data. Next one being deploying the data product. There, of course, we should be using the tools like Terraform, using the DevOps pipelines and Synapse pipelines, and ADF if it is needed. And then setting the privacy is, of course, through the Azure AD groups, and using resource groups, registering your data assets in Purview, and yeah, making this all automated using infrastructure as code. And like I was saying, that it's going to be Synapse Serverless, web app, and Azure Functions, using which we want to build a data product. We would also like to document the APIs if we are building. So we can use like Open API standards to document the APIs. We can use Purview to document our data sets. So these are the things these are the tools which we can definitely use to build the whole life cycle of a data product. Looking into the create DP capability, that's the create data product capability. I have come up with a pipeline of workflow which looks like you have data present on storage layer, be it in Delta Lake or be it on data lake itself. And then we have a function. What it does is it is an event-based trigger function which uses blob input binding, data input binding and output binding as well. Scans the data over here and then creates a file which sort of a metadata trigger for the pipeline, Synapse pipeline. And then the Synapse pipeline is going to read that metadata and create external tables in Synapse. And then that's going to be used through a web app to read the data. So that's, for me, it's how a create data product can, Synapse can leverage this capability. So yes, so like I was saying that we do have a event-based trigger which scans the data lake coming in, and whenever a new blob is created, it creates a metadata file which which is further used to trigger the Synapse pipelines. Using that trigger file, what it does is it calls the stored procedure and creates the schema, create the external tables to serve the data. And the last one which it goes is building APIs, where again it's going to at the backend call a stored procedure and going to fetch the data at the endpoint whichever is called by user. So I wanted to demo two of the basic principles used to build this. One being generating the logical data warehouse based on metadata trigger, and another one being API endpoints. I have taken the references from internet. There was a very good one available about creating the Synapse pipeline. But let me first this. Yes. So like I was saying that if we have a metadata trigger file which contains about what are the external table, what's the external table location, what's the file format being used, and where do we want to store the data, all those metadata getting created through the Azure functions. And if we use that to trigger a pipeline, which what it does is looks into the metadata file and then reads the data, passes it to the activity to create the table, and then that's should be created over here. So it does create a table, and just see if it has got any data. So that's how I feel that dynamic SQL queries are going to be one of the building blocks to create the framework. And the next one could be in the API creation. Over here, I do have a very bare minimum code defined to build an API to fetch the data. What it does is it's going to call a stored procedure, which could be a very generic one, and then use that to fetch the data from there. I have one created which says that power uses data. I'm going to run it locally and show that how that. Make this run, I need to get the token to authenticate through pipeline, and that's I'm going to fetch here. Wait. This. if I will list. That has started my, and look at, it should give me the data back. So these are the building blocks which would be very handy to build a framework. And once we have that ready, this could be reusable across multiple domains wherever, and mostly the source aligned data domains, because you have very less transformation to be done over there. So even the stored procedure can be dynamically created over there easily. So this is just an example that how it can be put up every different place. And coming to the last one, which is the summary of it, that using this way, I feel that we could build candidates for data product. Saying candidates for data product, meaning that, of course, first you bring it, is it healthy enough to be used and being scored over across the nodes on the mesh. You use it or you discard it based on how long it is being used. So the ratings and everything goes on. And then, like I said, it's going to support the create data product capability. What needs to be done over there, that it needs to be changed with other tool sets, like registering it as an asset in Purview, deploying it using ICS code. So yeah, those are the things need to be done. What it gets us is, if it is not going to work, it's like fail first and fail fast is what it enables us to do. And then, yeah, also the auto trigger of jobs and generating stored procedure based on event triggers is what it is. The references which I have taken are, of course, through the book of Jhamak Degunani, and then all these blogs. So that's all about I had to say about data mesh.